Welcome to NCIX Tech Tips. Today we have kind of an interesting topic. When I was filming a blog video on the Intel Turbo Boost gadget, I actually noticed that one of my coworkers' PCs, he uses this for video rendering, is running at 100 degrees on the CPU core. This is a Core i7 Extreme 965 engineering sample, and it's running so hot that when it reaches those temperatures, the CPU will actually degrade its own performance in order to protect itself from completely overheating. So I looked at his build, I went, okay, he's got a high-end machine running a stock heatsink in an old crummy case, so we need to find a way to do a bit of a renovation project on this PC in order to get those CPU temperatures under control, and I figured what better way to do it than on video. So we're going to walk you through cleaning and replacing the thermal compound. We're going to try a new CPU heatsink, change the case, and then add some case fans and show you just how low we can take these 90 to 100 degree CPU temperatures. So the first thing we're going to attempt is free, okay? We're going to go from least expensive to most expensive sort of today. So we're going to take off the CPU cooler that's on there, which looks just like this, and we're going to replace it just with a stock CPU cooler, stock thermal pad, see if maybe there was user error or something else causing the issue with this computer overheating. So the only change we made was I took the same heatsink and reapplied it using the stock thermal pad, okay? So the one that was on there was a little bit dusty. I'll get the cameraman to come in and have a look at this. And it had pretty poorly applied thermal paste on the bottom of it. This is my coworker's doing. And you can see here that we've actually seen a substantial temperature drop. Our room temps are the same, but we're down to about 83 degrees on the highest core, which is about a 15-degree improvement just by putting the same cooler back on. So we've seen a big improvement so far. We're running at about 80 to 85 degrees on the CPU. That is still way too hot. So the next step for us is to take that stock cooler off, and we're going to replace it with an aftermarket cooler. So the one I've picked here is the Noctua NHC12P SE14. Should have pretty good compatibility. It's nice and low. I actually did an unboxing, which you can check out on my video blog. And so now I'm going to install it in time-lapse, slow motion, fast motion, whichever. We're booted back up into Windows, so let's have a look at what kind of results we got swapping out the stock Intel cooler with this huge Noctua cooler. So we've gone from 85 degrees on the hottest core down to 71 degrees. That is a 15-degree drop almost just by swapping the cooler. But there's still more we can do, because I would imagine that putting a high-performance component in a tiny little oven-style case like this is just not going to yield the best results. So the next step in our thermal controlling discovery voyage episode would be the Antec 300. So we're actually going to completely transplant this computer into a case with proper ventilation for a high-end PC. Okay, so thank you for sticking with us as we tried everything from replacing the thermal compound to adding a new CPU cooler to completely changing the case from this old one with no ventilation to a new Antec 300. And I want to have a look at our final results here. So after we changed the case, we've got our crying out loud, NHC12P SE14 CPU cooler in there, and all of our CPU cores are now hovering in the mid to high 60s range, which is a much more comfortable temperature for a CPU. But there are a couple things I do want to explain about our methodology today. First of all, we're using an engineering sample CPU, which is known to run a little bit hot. So this is a kind of a worst case scenario, okay? Second thing is our room has been anywhere from about 23 to 25 degrees throughout all this testing. So you should take all of our temps as kind of plus or minus 2 to 3 degrees in terms of accuracy. Now, if you try all these steps and you find that you're still running into trouble with your CPU temperatures, there are other things you can do. As you can see with the 300, we've actually even got additional spaces for more ventilation fans. So in the front, we could potentially install another 2. And then if we had a high-end graphics card in this PC, which we don't, we could also install a 120mm fan right on the side panel, blowing fresh air down at the graphics card. The last thing that you can have a look at is, what is your cable management like? Sometimes you can get dramatically better temperatures just by rearranging your cables for optimal airflow through the PC. And one thing that helps with this is a modular power supply. So if you have a non-modular power supply, which by the way you should check out our tech tips on, it can make it a lot more difficult to hide all of those additional cables that block airflow. So you can see the True Power 550 watt we have in here only has about 8 cables coming out of it to power a reasonably high-end PC. Anyway, thank you for checking out our NCIX Tech Tips today on CPU thermal management.